Hello everybody and welcome back to this tutorial, and right now let us continue with our multi-threaded programming. We only mentioned in the previous tutorial, and we also said why do we need that in order to implement it into a threaded server. But now, before we actually do any of that, we need to introduce ourselves with the threading library and explain what threading is. So first of all, running several threads is very similar to running several different programs concurrently at the same time, but they have multiple benefits, such as multiple threads within the same process share the same data space with the main thread, and therefore basically they can share information or communicate with each other more easily than if they were separate processes. Now, threads are also sometimes called lightweight processes, and they do not require much memory overhead. They're basically cheaper than the process itself. So basically, threading is much more faster, and also a thread has a beginning, an execution sequence, and a conclusion. So basically, once you're creating a thread, you need to know exactly for what are you creating the thread, what will be the purpose of the thread, and what will the thread return at the end. Now, the thread has an instruction pointer that keeps tracks of where within its context it is currently running. It can be preempted or interrupted. It can temporarily be put on hold. It also known as sleeping while other threads are running. Now this is called yielding. There are also two different kinds of threads. Now the most common names for them are the kernel threads and the user threads. Basically, the kernel thread is a part of the operating system, while the user space threads are not implemented in the kernel. So the kernel thread is something that is running more deeply in the system itself. Okay, now there are two modules which support the usage of threads in Python 3. The first one is _thread. Let me just open the idle. You can import it like this. Import _thread or import threading. Those are two modules that basically allow us to use threads, and they can both be used. Now the thread module has been deprecated for quite a long time. Users are encouraged to use the threading module instead, which is the second one that we imported right here. Hence in Python 3, but in Python 3 the module thread is not available anymore. However, it has been renamed to _thread, which is the first one that we imported right here for backwards compatibilities in Python 3. So we are going to take a look at both of them, but for now on, let us see how we can simply just start a new thread. So basically, to spawn another thread, you need to call the following method that is available in the thread module. So we're going to use this module right here, and in order to spawn another thread, you will simply just specify _thread dot start _new _thread. Now a thread, this function right here would start a new thread, but it needs to have some arguments. Now what the arguments would be is the first argument would be basically the function on which you want to start the thread. Now that function can basically be anything. So let's say you code a function that is going to print hello world every 10 seconds, and you want to specify it right here to run while the rest of the program is also executing, and you would specify it right here. But also the second argument would be the arguments to that specific function. So args right here, if there are any. If there are not, simply you don't need to specify this. But if your function takes arguments, you would specify them or paste them right here. Then the threading library would start the thread, and then it would simply just print hello world every 10 seconds, as well as running the rest of the program at the same time. Okay, so this is the basic syntax for creating a thread with the import thread. Of course, we're going to take a look at the example. This is just for now on a syntax. Now, this method call enables a fast and efficient way to create new threads in both Linux and Windows. Now the method call returns immediately, and the child thread starts and calls function with the passed list of arguments. Now when the function returns, this thread will terminate. Now here, in the previous example of syntax, the args is a tuple of arguments, so basically it uses an empty tuple to call function without passing any arguments. The basically example of this would be, so let's say we do something like this. So we imported threading. Let me just go right here. We'll create a new file. Let us enlarge this. We will save it onto our desktop right here. So go to the desktop, thread1.py. We'll save it right there. We're going to import underscore thread, and we're going to import time. Now we already introduced ourselves with the time module. Right now, let us see how we can implement these two modules together in order to make something that will be easy for you to understand. So first of all, we will create a function, and the function will simply be called print time, as it will print time. So print underscore time will be our function. The function will take two arguments, which is going to be the thread name, which is the first argument, and the second argument is going to be delay. And I will explain it just in a second, as you will see right now. What we will do right here is we'll create first of all a simple local variable called called count. So count equals, and we will edit the value of 0. So this is the local variable, only belongs to the function itself, and it has the value of 0. Then we are going to enter a while loop. So while count is smaller, we just find the okay, so here it is. Took me quite a while to find the smaller sign. So while count is smaller than 5, then 2 dots. Then we will simply just call the time library, and from the time library we will call the sleep function, and what we will specify right here, so time.sleep, which is the amount of seconds that the program should not do anything, and we'll simply just specify the amount of seconds to be equal to the delay variable that we parsed to this print time function as a second argument right here, as we can see. Okay. Then once the program sleeps, we will simply just increase the count by 1, so plus equals 1, which will add a 1 to the count variable, and right after it we can print something like %s, okay, so %s dot 2 dots %s, and what the actual two arguments will be is the first one will be thread name, and the second one will be time.ctime, in between the brackets time.time. Okay, let me just see whether I am missing a certain bracket right here. 1, 2, 3, 4. Okay, so we need one more bracket. 4 open and 4 close. This is first one, second one, third one, and fourth one, and we also have 4 closed. Okay, so press here enter. Basically this is our function for the thread. That is all the function will do for now on. And now we're going to create 2 threads. In order to create 2 threads, we can simply just, in order for our program to execute properly, we'll use the try and except rule. And in the try statement right here, we'll try to call the start new thread function that I showed you before in the syntax example. So underscore thread dot start underscore new underscore thread, and basically in between the brackets we need to specify 2 things, as we already know. The first one will be the print time, and the reason why we're specifying print time is because that is the name of our function. And the second argument, oops, not here, print time, accidentally deleted that, so print time is the name of our function, comma, and now we need to specify the arguments. So we know that our function takes 2 arguments. First one is the name of the thread itself, and the second one is the amount of seconds that the program will sleep once it calls the time.sleep function right here. Okay, so we will open our brackets right here in order to specify the arguments. The first argument, let's say we want to call the thread -1. Okay, it will be specified between the double quotes because this is a string basically. And the second argument, let's say we specify that the amount of time that we want to delay the program or our thread will be 2. Okay, then specify comma right after it. Make sure that you have 2 actual brackets open and closed as we have right here. And we're also going to start another thread, so _thread dot start _new _thread. And what we will do right here is we will open and close brackets once again and call the same function, which is print time. Just right now we're going to call the threads differently, and we're also going to specify the different amount of seconds for the program to delay. So we'll call this one thread -2 and then comma 4 seconds, and then we leave these 2 brackets closed. In the accept statement we can simply just print failed to start thread. Doesn't even matter, we can simply just print anything we want, and all we're left to do is call this program. So what we will do is we will simply just while one or while true. Basically while one and while true is the same thing. It will basically execute forever, and then we will specify just pass. So this is the while true loop that will not simply do anything. Okay, so save this program right here, save it just like that, and then simply let us run the module. We started it. We can see thread 1, we can see thread 2, thread 1, we can see that they're executing at the same time and they're printing those statements at the same time. So both of those threads are executing it at the same time. Basically just one of them is going to be executed every 2 seconds, while as the next one has the delay of 4 seconds. Therefore they are not interacting with each other in the means of this actual order being 1 2 1 2. It is rather being mixed up, and we can see that this program right here, it will basically execute forever because we specify the while true loop, or the program itself will execute forever, but the printing statements have already been finished because the count variable has reached the value of 5. As if you remember, every time we actually print this statement, we simply just increase the count variable by 1. Therefore, this is not printing anything anymore because both of those count variables have received the value of 5. Therefore, we will just keyboard interrupt this as the program goes into an infinite loop. So you will have to simply just press Ctrl+C to stop. Now, although this is a very effective for low-level threading, the thread module is very limited compared to the new threading module. So this was the example of the thread module, and right now let us see the example of the threading module. So I will just restart my idle right here. And basically we already know how to import the threading module. You simply just specify import threading right here, press here enter, and you simply imported the threading module. So the new threading module, which is this one, it is included in Python 2 and in Python 3 as well. It provides much more powerful or high-level support for threads than the thread module that we discussed in the previous example. So basically the threading module exposes all the methods of thread module and provides some additional methods as well, such as, for example, threading.activeCount, which you specify simply just like this, active count. Now we will not call this because it will return an error, but what this function from the threading module simply does is it will return the number of thread objects that are currently active. Now another function, you can simply just specify threading.currentThread, and what this function does is it will return the number of thread objects in the caller's thread control. So basically it will return, as it says, it will in the caller's thread control just check out how many thread objects are there, and it will return the integer value of those thread objects, or the number of those thread objects. Now another important function that is in the threading library is the enumerate function, which simply returns a list of all thread objects that are currently active. Now, in addition to all of these functions, or these three functions, the threading module has the thread class that implements threading itself. Now, the methods provided by the thread class are simply these ones. So, for example, you have the run method from the threading library from the thread class. The run method is the entry point for the thread itself. You have the start method. The start method simply starts a thread by calling the run method. You have join time, which you specify the syntax wise like this. So join, and in between the brackets you specify time, and basically the join waits for threads to terminate. You want to join the thread at the end of the execution of the process that the thread had as its task, and therefore right after it the thread will terminate. Another function from the thread class is isAlive, with specified A capital. The isAlive method checks whether a thread is still executing. Common sense, as the name says, is it alive. Now another thing is the getName method, which will simply return the name of a thread itself, and the setName, which will simply set the name for a specific thread that you want to set the name for. Okay, so those are just some of the important methods from the thread class, as well as the important functions from the threading module. Now let's see an example of how we can simply create the thread using the thread module. Okay, so we are going to first of all open up a new program, as we will see an example of the threading library. Now, to implement a new thread using the threading module, you have to simply just do the following. First of all, you need to define a new subclass of the thread class. You need to override the init function or the init method to add additional arguments that you might need. And then you need to override the run method to implement what the thread should do when started. Now, we already are familiar with all of these basic terms, such as, for example, overriding. We took a look at that in the classes section. We also know how we can define a subclass of the thread class. And right now, let us see how we can simply just do all of that. So once you have created the new thread class, you can create an instance of it, basically, and then start a new thread by invoking the start method from the thread class, which in turn calls the run method. Okay, so in case you don't understand, let us see a simple example of that. So first of all, we will import threading, and we will also import another library, which is the time library, so import time as well. Now, first of all, what we're going to do is we're going to set a certain variable exit flag to be equal to 0. Now, I will explain it as soon as we get to the exit flag execution. Right now, let us just leave it right here. So simply just create a variable called exit flag and set its value to be equal to 0. Then we will create a class that is going to be called my, or let's go with the smaller letters, so my thread. What this class will take in its argument is the threading.thread, as it is inheriting everything from that specific class from the threading library. I already told you that in the threading library there is a thread class, therefore we are going to use its methods in our own class. So we created the class myThread, and from this library we used this class. Okay, then specify 2 dots. The next thing is we need to create the init function as usual, so simply just specify def __ init __. And what this init function will take as an argument is, first of all, it will take, of course, the self argument, then the thread ID, because threads have IDs, their threads have their names, which is going to be our third argument to the init method right here, so the name of the thread, and the counter. Okay, so 4 arguments, or basically 3, because the first one is self. And once you specify all of them, add the 2 dots, and now let's define all of those arguments one by one. Okay? So in order to define the thread itself, you can simply just specify threading dot thread dot and then call the init function on the self argument, so underscore underscore init underscore underscore, and in between the brackets we need to specify the self argument as we are in the class. Okay, the next argument that we need to define is the thread ID, so we can simply just specify self.thread or self.thread ID equals thread ID. Self.name will be equal to name, and self.counter will be equal to counter. Okay, so we defined all of the 4 variables that we had defined in the init class, in the init method of our class. Now we need to define the run function that is going to have the self argument, so def run, and all we need to simply specify right here is what is going to be ran once this actual function is called. We simply just want to print different statements right here. So the first statement will be printing, let's open and close double quotes, starting, add a space, and we will simply just print what we are starting, and by that I mean we will print the name of the thread, so plus self.name, which is our variable right here. This is going to be the first thing that the run function will execute. The next thing but the run function will execute is going to be the function print time, which we took a look at in the previous example. Just right now we're going to code it a little bit differently right after our class, so let us just call it right here and then we will code it below. For now on, what this actual print time function will have as its arguments is going to be the self.name, the self.counter, and the delay. Okay, so simply just specify it just like that. Okay, and then the last thing that we want to execute in this run method is going to be print exiting plus self.name. Simply we will just print exiting and then the name of the actual thread itself. So right now down here let us code the print time function a little bit differently. So it will take 3 arguments as we specified up there in our class. So print time, the first argument will be the thread name, of course, the second argument will be the delay, and the third argument will be the counter, which we specified in our class as well. Now what we're going to specify right here is while counter, and basically while counter, so 2 dots, if, and now we're going to implement the exit flag variable that we coded at the beginning as the actual variable that is going to define whether a certain flag is simply just open or whether should we close it with the exit function. So if exit flag, then if exit flag we will specify thread name dot exit, which is going to be the self.name argument, as we can see right here. So self.name is equal to the thread name. We're going to call the exit function, which will exit the thread, and after it we'll simply just type time.sleep, and we will sleep the amount of delay seconds. Okay, right after it we will print something like this, so %s, 2 dots, %s, so basically the same print statement as in the previous example. Just right now we're going to include the thread name, so thread name from the self.name variable, and we're also going to print the time, so time.cTime and then time.time. Okay, let us just count the brackets, whether we have closed and opened everything. 1, 2, 3, 4, and then 4 close brackets. Okay, so everything is good by now, and we will simply decrease the counter right now by 1. So minus equals 1. We'll simply decrease it. All we are left to do right now, right after it, is simply just create the new threads and start them. So in order to do that, let us first of all create new threads, and we can simply just call them thread1, which is going to be equal to my thread class, we are simply just calling this class, and what we will specify right here is these variables right here. So we will specify the thread ID. This one will have an ID 1 because it is the first thread we create. Then the name of the thread will be equal to thread-1 as in the previous example, and the counter value will be equal to 1. Okay, so simple as that. The thread2 will be similar to this, so we will call it an object to a thread class. The actual ID will be 2, the name will be thread-2, and then comma, and let's say 2 as a counter. All we're left to do is simply just type the start function onto these threads in order to start them. So thread1.start will start the first thread, and thread2.start will start the second thread. Now make sure that we also call the join function, which will at the end of the execution join these two threads and terminate them. So we'll simply just specify thread1.join and thread2.join, and then at the end of our main program we can print exiting main thread. Okay, so basically this would be our entire program. Let us see how it should run. It should execute both of these functions, or start first of all both of these threads at the beginning. It should execute these print statements right here, as well as, this print statement right here, which is going to print the thread name as well as the current time at which it is running. And then right after it finishes, while the counter reaches its desired value, it should simply just exit the thread1. It should print exiting thread1, which is right here, and then it should exit the main thread as soon as these two functions are executed. So first of all, save this to the desktop. Let's call it threading1.py, because this is the threading library or module that we used. We saved it. Let's run it. It says starting thread1, starting thread2. We can see those print statements being executed. The thread1 is executed or exited. The thread2 is now exited, and then it exited the main thread. So we can see that everything worked perfectly. We managed to actually run our program. It printed out different values. Some of them it printed out at the same time, as we can see right here that it printed out in the same line, which is an actual bug. As we can see right here, thread2 and thread1 printed at this time, which is the same time. Right here you can see. That means that they were executing at the same time, therefore our threading works. And at the end we joined these two threads, terminated them, and basically simply just exited the main thread right after. Okay, so another thing that you should know about is the synchronization of the threads themselves. So the threading module basically provides with Python the threading module provides with Python or includes a simple to implement locking mechanism that will allow you to synchronize threads. Now, a new lock is created by calling the lock method, which returns the new lock. Now, the acquire blocking method of the new lock object is used to force the threads to run synchronously. Now, the optional blocking parameter, basically it will enable you to control whether the thread waits to acquire the lock or not. Now, if the blocking is simply just set to 0, the thread returns immediately with a 0 value if the block cannot be acquired, and with a 1 value if the lock was acquired. Okay? Now, if the blocking is set to 1, the thread will simply just block and wait for the lock to be released. The release method of the new lock object is used to release the lock when it is simply just no longer required. So we can simply just take a look at that as well. We're going to implement it onto our own program. So we'll just do a little bit of modification to it, as we can see right here. The exit flag, we can simply just close it right here. We don't really need it at the moment. Just type it right here. The class myThread, we will leave it with the same name as well, with the same argument. The def init function will also take the same arguments as it did before. We'll leave the threading.thread, self thread, defining all of this, we will leave the same as in the previous example. The run self function is something that we will change. So first of all, we will print this statement right here. Then we need to get the lock to asynchronized threads. So we can simply just do that by specifying thread lock dot acquire, open and close brackets right here, and then we will print this same statement right here. Let us simply just, for example, change this from 5 to 3 just for the purpose of the program. And then at the end, we will not print exiting threads, thread 1 and thread 2. We will simply just delete it. It doesn't really have any point. What we will add, however, is the thread lock.release. And why we are doing this is it will free lock to release the next thread. Okay, so simple as that. Let us go down to our print time function and see whether there is something right here that we need to change. We parse the arguments thread name, delay, and counter, and then while counter, we will delete this exit flag right here, as well as the if statement, as we don't really need it at the moment. We will leave the time sleep delay, we will print this same thing, and we will return the counter minus equals 1, which is going to be executed until the actual counter reaches 0, therefore it will stop right after it. Okay, now right after that, before we actually create our own threads, we need to implement the thread lock, so we can simply just call it right here, because this right here is not really something that exists. We need to really create it, so we will create it at the beginning of our program just by simply specifying thread lock, which is going to be equal to the lock function from the threading module. So threading.lock. We will create the thread lock right here, and we will create a list, or an empty list in our case, which is going to store our threads. So threads equal open and close square brackets in order to define a list. Then we'll proceed to starting these threads right here. As we can see, we created thread 1 and thread 2, starting new threads. And instead of actually joining these threads, let me delete these two statements right here. What we will do is we will add threads to the thread list. So how we can do that is we can simply use the append function, as we saw in the list section when we learned about lists. We know that we can append different elements using the append function. So we will just use threads, which is the name of our list right here, and we will append thread 1 and thread 2. So append, in between the brackets we specify thread 1, and the next statement threads.append thread 2. Okay, so simple as that. And before we actually close the program, or before we actually print this exiting main thread, we want to simply wait for all threads to complete. So we'll just use the join right after we appended it. So for the for thread in threads list, so we'll just simply type for t in threads. So for each element in our threads list, we want to specify t.join, which will join the thread and then terminate the thread execution, as well as printing this exiting main thread and closing our program. So this should be about it that we should change. Let me just save this and run it in order to test it right here. We can see restarting the program. It is printing this until the actual counter reaches 0. We can see right here it still prints it out. We can see it executed at the same time, it synchronized it. We can see right here we now have thread 1, thread 1, thread 1, and then we have thread 2, thread 2, thread 2, and at the end we exited the main thread. Now this was executed by the help of the actual lock that we defined right here. Okay, so simple as that. Now another thing that you might be interested in is the multi-threaded priority queue. Now the queue basic module simply allows you to create a new queue object that can hold a specific number of items. Now there are following methods that basically control the queue, or that we should use once we actually implement the queue library. Let me just go right here, open up my idle. And first of all, in order to actually import the queue, you simply just type import queue. You can see it is an already installed and pre-built library in Python 3, therefore you can simply just import it without installing it. And a few different functions that you might need to know in order to use this actual module is the get function, which is a method that basically removes and returns an item from the queue itself. We also have the put function. This function adds items to the queue itself. The queue size method returns the number of items that are currently in the queue itself. Okay, so simple as that. Another method that you might want to know is the empty method, which returns true if queue is empty, otherwise it will return false. So this is basically a boolean value, or it will return a boolean value. And another method that you should know is the full function, which returns true if queue is full, otherwise false. Okay, so another boolean method. So right now, at the end of our actual threading task, let us see how we can implement this queue module into our existing program. So first of all, I will close this. We will go at the beginning right here. And before we do anything, let us import queue. So we imported the library itself. And let us set back the exit flag to 0 right here, as we might need it in the program itself. Let us go line by line and see whether there is something that we need to add. Right here we have the thread name, and instead of the counter, let us specify queue. Okay, and you will see why. Just right here at the counter, you simply just specify self queue equals queue. So this is another actual variable that we'll have as a part of our class. In the run function right here, there are a few things that we need to change. First one is adding the exiting right here. First of all, let us delete everything that we don't need. We'll delete these three lines. We will leave the starting plus self name, and right after it we will call a function that we will name process data. Now this function is not something that exists, we will need to code it, but before we actually code it, let us just call it right here. This function will take two arguments. First one will be self.name, which is the name of the thread itself, and self.queue. Okay. Another thing that we need to add right here is the exiting statement. Well, it doesn't really have to be added right here, but let us add it just in case. And then we will add this self.name in order for us to know which thread is exiting. Okay. Now we can code the actual process data function. So let us go right here, def process underscore data. And we know that it takes two arguments. First one is the self.name, while as the second one is self.queue. So we'll specify right here thread name comma queue. Okay. And now we're going to use our exit flag that we added at the beginning once again. So while not exit flag, exit flag, we will use the queue lock. So queue lock dot acquire, we will use it right here. If not, work queue dot empty. What we will do is we will simply just set the data to be equals to queue.get. Okay, so simple as that. Now before you actually ask what this is, don't worry, we will define all of these values later on in our program, all down here, as well as the redefining the thread locks and thread list and all of that. But for now on, let us just name them like this. Don't worry, this is not something that exists, this is something that we need to define. And right now, queueLock.release, which is the function that we will call right here in order to release it. And then the print statement comes right after, which is going to be %s, and then processing %s, and then we will add with the % the thread name and the data itself. and you will see in just a second what this will perform as soon as we actually code the else statement, which is going to simply just do the same thing, which is qlock.release, and then it will sleep for 1 second, so time.sleep, and specify 1 second right here. Okay, so simple as that. Now we can delete this print time function as we don't really need it in this example right here, so let us just delete it. And let us define all of these things that we used in the actual function process data. So first thing, let us delete this as well. And we will simply just type here, first of all, we will create a thread list, but it will not be an empty list as in the previous example. Right here, what we will do is we will also put the names of the threads in the list at the beginning of the program. So thread 1, thread dash 1, then comma, thread dash 2, comma, and then thread dash 3. Okay, so this will be the name of our list, the name of our threads that are stored in this list right here. And we will also have a name list, which is going to simply just store the names as 1, 2, and we will store it up to 5, so 3, comma 4, and then the last one, which is going to be 5. Okay, so we have two lists. One of them is the thread list, and the second one is the name list. Okay, and then right after it, we noticed right here that we used something called qlock right here. So we need to define what qlock is, and simply what qlock is equals, and that is basically a lock from the threading library. So threading.lock, we already used it in the previous example. Just right here we redefined its name, and then the next thing that we noticed that we used, and that doesn't simply just exist like that, is the work queue. So specify right here work queue is going to be equal, and now we will use the queue library and specify the object queue.queue. And it takes an actual input of 10, which is the argument for the queue class from the module queue. And right now at the end we will create an empty threads list, which is going to be the same as before, and the thread ID will be set to 1. Okay, so these are all of the things that we need to predefine at the beginning of our program, and right now we are ready to create new threads. So simply we will just delete all of this. Okay, so we can leave this 14 threads t.join, I think, but we will delete this right here, and we'll simply just create the new thread. So in order to create it, we will simply just for tname, which stands for thread name, in the thread list, and thread list is a list that already has names predefined right here, as we can see, thread 1, thread 2, thread 3. Okay, so for tname threads list, what we will do is we will simply just specify thread to be equal, and then we will call our class, which is the myThread class. So my thread, which will take 3 arguments, which first of all is the thread ID, tname, which is the name of the thread itself. So in the first time it will take the tname as thread 1, in the second time it will take the tname as thread 2, and in the third time the name or the name of the thread will be thread 3. Okay, so simple as that. And the last argument that it takes, as we can see right here, at the beginning we did change it. We have something called queue, which is simply just our queue, and then we will specify right here to parse as a third argument the work queue, which we defined right here. Okay, so simple as that. And all we are left to do is start this thread as soon as we parsed all those arguments. So thread.start, and we will append it to our empty threads list as in the previous example. So threads.append, and we will add thread right here. And you might be asking, where does this thread ID come for? Well, we will simply just, since we are passing it in the actual for loop right here as the thread ID, we want to increase it so not every thread of all of these 3 threads gets the same thread ID. So the first one will get thread ID number 1, And then once it goes to the beginning of the for loop, we need to increase right here thread ID plus equals 1, so that the next thread can have the ID of 2. Okay, so simple as that. Right now, the next thing we want to do is fill the queue up. So in order to do that, let us go down here, and we'll simply just specify queue lock. So queue lock acquire right here, and now we need to use this names list right here. So in order to use it, we will simply just perform another for loop. So forward in name list, oops, it is not capital name, so name list, we will put the word into our work queue. So work queue, as you remember the put function, I explained all of these functions at the beginning, what they do briefly, and we'll simply just put the word into our queue function. And then we will call, after the for loop is finished, we will call the queue lock to release. So simple as that. Okay, we will also check for the queue to be empty, so we will wait for queue to be empty, simple. And how we can do that is we will simply just use while not, and we will use the empty function for the queue library, which I also explained. So while not work queue dot empty, we can use pass. So simply just to pass, we will not perform any task right here, and all we need to do is notify the threads when it is time to exit. So we will simply just set the exit flag to be equal to 1 right here. So exit flag equals 1. We'll simply just put it right here, and then we will wait for all threads to complete and terminate with this for loop that we didn't even change from the previous example. And at the end, we'll simply just print exiting main thread. So what we are expecting right here is that the threads start one by one. So starting thread 1, starting thread 2, starting thread 2, and then starting thread 3. Then the thread 1 will be processing all of these values that we specified in the name list, which will say simply thread 1, for example, processing 1, and then a different thread will process the different number, which is written by the string right here. And as soon as they finish all of these 5 words right here, they will all terminate, or all threads will terminate, and then the main thread will terminate as well. So that is the plan. Now let's see how that will work. If we save this and simply just run the program or run module right here, we can see restarting, exiting thread 2, exiting thread 3. Let me just see right here. Let's see, for some reason it didn't really print it out. Let us see why is that. So we did set the exit flag, maybe that could be the problem. So define process data. Wait, let me just delete this, or let's leave it just at the actual hash. So let's leave it as a comment just for a case, so we don't really try to find the error. In case that is the error, we will run this. Yeah, okay, that is not the error. Let us remove that. The threads list has the thread 1, thread 2, thread 3. Processing, then the data. Then we sleep for 1 second. It is as if this this function right here is not even closing. QLock.acquire, that is good. If not, for Q.empty, so we check if it is empty. If it is not, then we get the data, we will release the QLock, and then we will print processing, and then we will simply just specify right here the thread name and the data. In the else statement, we also release, which should be good. We have defined everything right here. Then we create new threads, so we create it simply by calling our own class. Then we append the thread. We also increase the thread ID by 1. The QLock acquire is called right here. Then forward in name list. Let me see right here. QLock.release while not QWork empty pass, and then exit flag The problem right here is, I would say, okay, never mind, we did call the process data. I for 1 second thought that we didn't really call it right here, but we did call it. Well, for some reason this doesn't want to work, but I assure you that once I find the error, I will make sure to notify you in the next tutorial. For now on, this one actually got a little bit too long, so we'll just cut the tutorial short here. We basically learned everything we needed about threading in this tutorial right now, and therefore we can continue with our socket programming and see how we can briefly implement the threaded server. So right now, by now, you might also have an idea how to do that, and we'll see how we can do that in the next tutorial. So hope you enjoyed this lecture, and I hope I will see you in the next one. Bye!